Welcome back, everyone, to the Bootstrapped AI podcast. You know we love to break down complex AI concepts so all of you everyday users out there can really understand this stuff.
Yeah.
That's our Neural Knowledge series.
I love it.
And today, we are diving into something that sounds pretty futuristic.
Oh.
I'm talking about Generative Adversarial Networks.
Wow.
Or GANs for short.
Yes.
The art of synthetic data creation.
Very cool.
We're going to try to untangle what they are,
Yeah.
how they work,
Yeah.
and why they're making waves
Mm-hmm.
across industries.
I'm excited.
Yeah, me too.
Okay.
So before we even get started,
Okay.
I'm already trying to wrap my head around
Yeah.
how these networks can create data that is like nearly indistinguishable from real data.
It really is fascinating. It's incredible how they've advanced. But to start off, can you just break down for me what a GAN is at its core?
Yeah.
Sure. Imagine a counterfeiter
Okay.
meticulously trying to create fake money. Okay.
I'm with you.
So convincing that it fools even the most seasoned detectives. Picture a detective tirelessly studying counterfeit bills, honing their skills to detect even the slightest flaw.
So it's like this constant game of cat and mouse.
Precisely. That's the essence of a GAN.
Yes.
It's a system of two neural networks, a generator, our counterfeiter, and a discriminator, the detective.
Okay, so the generator is trying to create the fake data?
Yeah.
And the discriminator is trying to call it out.
Exactly. The generator starts with random noise
Okay.
and transforms it into synthetic data samples, aiming for ultimate realism.
Okay.
The discriminator receives both real and generated data, tasked with accurately classifying them.
I love that this adversarial relationship. Can you explain how this back and forth plays out in the training process?
Sure, as the generator crafts its fakes,
Okay.
the discriminator provides feedback, essentially saying, gotcha, when it spots an artificial creation. This feedback loop pushes the generator to refine its techniques, producing increasingly convincing data. Simultaneously, the discriminator sharpens its detection skills, becoming more adept at spotting subtle inconsistencies.
So they're constantly pushing each other
Yes.
to get better. Does this ever reach a point where the generator can, like, consistently fool the discriminator?
The ideal scenario is a dynamic equilibrium where the generator becomes so skilled that the discriminator can no longer reliably distinguish between real and synthetic data. This indicates the generator has learned to effectively mimic the underlying pattern and distribution of the real data it was trained on.
That's wild. So what's the point of creating all this synthetic data?
Right.
Like, how is it actually being used out there?
The applications are surprisingly diverse and impactful.
Okay.
One prominent use is in image generation.
Okay.
GANs are used to create photorealistic images of objects, scenes, and even faces, fueling those websites that generate images of people who don't exist.
That's both impressive and a little unsettling.
It is a little creepy. Yeah.
What are some other uses that go beyond just creating fake images?
Yeah, beyond the novelty factor, GANs can address real-world limitations. Imagine needing vast amounts of data to train a self-driving car algorithm,
Okay.
but struggling to gather enough real-world scenarios. GANs can generate synthetic driving data, supplementing limited data sets, and accelerating development.
So they kind of act as like a data amplifier in a way.
Exactly. Data amplifier. I like that. That's good.
What about manipulating images? Are there other ways that they're used for that?
Absolutely. GANs are used to enhance existing images, increasing resolution, removing noise, and even colorizing black and white photographs. It's like having an AI-powered Photoshop toolkit.
That's pretty amazing. So you're telling me that this technology is really versatile.
It really is. Yeah.
What other image-related applications are there?
One fascinating area is image-to-image translation.
Okay.
GANs can take an image and transform it, maintaining the core content while altering its characteristics.
Right.
For example, they can turn a daytime photo into a nighttime scene, or convert a simple sketch into a photorealistic image.
That makes me think of like architecture or fashion design.
Absolutely. You got to be able to generate different variations with different materials, colors, textures. Exactly. The possibilities are vast. In fact, there's another type of GAN that excels at generating images from textual descriptions.
Wait, so you could literally describe something.
Yeah.
And the GAN would just create it.
That's the idea. It's called text-to-image synthesis. And it has huge potential for creative industries, advertising, and even accessibility tools for people with visual impairments.
Okay, so we've established that GANs can be used for a wide range of applications.
Yes.
especially in the visual realm. But I'm guessing there are downsides too, right?
Of course, there are.
There must be some challenges in working with these adversarial networks.
You're right, there are inherent hurdles.
Okay.
One significant challenge is training instability due to the adversarial nature of GANs. Finding the right balance between the generator and discriminator can be tricky. It's like trying to juggle while riding a unicycle. It requires delicate coordination.
So if one network gets too good, the whole system
Exactly. It's a delicate dance.
gets out of whack. What about mode collapse?
Another issue is something called mode collapse, where the generator might get stuck, producing a limited variety of outputs. Even when the real data is much more diverse, it's like our counterfeiter.
Okay.
Only mastering one type of bill, neglecting the others.
Okay, so these GANs are powerful,
Yeah.
but they definitely still have some kinks to work out.
Absolutely. GANs are a rapidly evolving field. Despite these challenges, researchers are constantly working to improve training stability, address mode collapse, and develop even more innovative GAN architectures.
Well, this has been an incredible overview of GANs so far.
Yeah, we covered a lot. We did.
But I'm eager to delve deeper into the specific types of GANs out there.
Okay, sounds good.
I feel like there's so much more to unpack.
There is a lot more. So in the next part of our deep dive,
Okay.
we'll explore the world of different GAN architectures, each with its unique strengths and applications. Stay tuned. Welcome back to the Bootstrapped AI podcast.
It's time to dive back into the world of GANs.
Yes, in the last segment, we kind of introduced you to these dueling networks, the generator and the discriminator, working together to produce synthetic data.
And we explored some pretty mind-blowing applications, like creating images of people who don't even exist, or speeding up drug discovery.
Right, and even some of the challenges, like the training instability and mode collapse.
Yeah, so today I want to zoom in a little and take a closer look at the different types of GANs out there.
Sure.
It turns out there are a lot.
There are many variations, each with its own strengths and quirks.
It's like the world of dogs, right? You have your basic breeds, like the Labrador.
Like your Labrador Retriever, and then your more specialized ones, bred for specific tasks.
Like the Border Collie.
Like a Border Collie.
Exactly.
So let's start with the foundation. What would you consider the baseline GAN architecture?
Well, that would be your vanilla GAN, the one that started it all.
The Model T of the GAN world. Simple, but effective.
Okay, so simple, but maybe not as flashy or feature-packed as some of the newer models.
Exactly, vanilla GANs use fully connected layers in both the generator and discriminator. They're a good starting point for understanding those core principles of adversarial training. But their limitations become apparent when you try to generate more complex data.
So I wanted to create a hyper-realistic image or compose a symphony. A vanilla GAN might not cut it.
Probably not. For those kinds of tasks, researchers have developed more specialized architectures, such as the deep convolutional GAN, or DCGAN.
DCGAN. That sounds a lot more high-tech.
It does represent a significant step up. From vanilla GANs, DCGANs incorporate convolutional layers, which are particularly good at processing images and other types of spatial data.
So if I'm aiming for stunning visuals, DCGANs are the way to go.
They're definitely a strong contender. The convolutional layers help the GAN capture the spatial hierarchies and intricate details that make images appear realistic.
So you could train a DCGAN on medical images.
To
help with disease diagnosis.
Exactly.
Okay, so we have vanilla GANs for the basics, DCGANs for Instagram-worthy visuals.
I like it. I like the way you think.
What other types of GANs are out there?
Well, one that's been getting a lot of attention is StyleGAN. And as its name suggests, it excels at generating images with specific styles.
So instead of just creating a generic image of a cat, I could use a StyleGAN to create a cat that looks like it belongs in a Picasso painting.
Precisely. StyleGANs give us this remarkable ability to control the fine-grained details of the generated images.
Wow.
Adjusting brushstrokes, colors, textures to mimic a particular artistic style.
So we're talking about AI that can create art that rivals human artists.
It's blurring the lines. And speaking of blurring lines, there's another GAN architecture that's particularly adept at image transformation.
You mean CycleGAN?
You got it. CycleGANs specialize in what we call image-to-image translation, where they take an image and convert it into another image with completely different characteristics.
So like turning a summer landscape into a winter scene.
Exactly. CycleGANs are like master illusionists in the world of images.
What's even more impressive is that they can achieve this
Mm-hmm.
without needing paired training data?
Yes, they can.
Wait, so you're telling me that you don't need a data set with like matching input and output images
You would think so. Typically, you would.
to train a model for image transfer?
You'd need pairs of images, like a photo of a horse
Right.
and a corresponding photo of a zebra to teach the model.
Yeah, like a visual dictionary.
Yes. But cycloGANs don't need that. They can learn to translate between two domains, even if you just have a data set of horse images and a separate data set of zebra images.
That's incredible. So they figure out the mapping on their own.
They essentially figure it out on their own.
They're like the self-taught
Here.
polyglots of the AI world.
I love that analogy. That's great.
Okay, so we've covered vanilla GANs, DC GANs, style GANs, cycle GANs. Are there any other important GANs out there?
There are countless others. The field of GAN research is incredibly dynamic. But one more I think deserves mention is the conditional GAN, or SIGGAN.
SIGGANs, what makes them so special?
Well, SIGGANs are all about control.
Okay.
They allow us to guide the data generation process by providing additional information.
So instead of letting the GAN run wild, we can give it some direction.
Precisely. You can give it a little nudge.
A nudge in the right creative direction.
Exactly. For
Okay.
example, if you're using a SIGGAN to generate images of birds,
Okay.
you can provide labels specifying the type of bird you want.
So you can tell it to create a robin or a blue jay.
Exactly. It's like providing the GAN with a creative brief.
That's really cool. So it opens up a lot of possibilities for very specific data.
It really does, yeah.
So if I wanted to generate a data set of people wearing different types of hats, a GAN could do that.
Absolutely. You could provide labels for different hats styles, and the SIGGAN would generate images accordingly.
This is incredible. It's amazing how researchers have taken this basic GAN concept and developed all these different variations,
I know. It's really remarkable.
each tailored for a specific task. It sounds like GANs are quickly becoming the Swiss Army knife of AI.
That's a great way to put it. But it's important to remember that despite these impressive capabilities, GANs are still under development.
Right, all those challenges we talk about, the training instability, the mode collapse.
Exactly. Those are still major hurdles.
But researchers are constantly working to improve them.
They are developing new techniques, pushing the boundaries.
It feels like we're really on the verge
Yeah.
of a synthetic data revolution.
It does feel that way, with GANs leading the charge.
Before we get too carried away with the possibilities,
Okay.
maybe we should take a step back and consider the implications of this technology.
You're right. With any powerful tool, especially one capable of creating such realistic synthetic data, there are ethical considerations to address.
Exactly. In the next part of our deep dive, we'll wrap things up by exploring some of these ethical aspects and how we can ensure responsible use of this rapidly advancing technology. Welcome back to the Bootstrapped AI podcast. In the first two parts of this neural knowledge series, we've been exploring the depths of generative adversarial networks, or GANs.
It's been a journey, a wild ride.
We've covered how these dueling networks work, the different types of GAN architectures, their applications.
Yeah, from generating realistic images and videos to pushing the boundaries of creative fields like art and music.
It's really changing the way we think about data.
GANs are truly revolutionary in the possibilities they unlock.
But as we've touched on before, with any powerful technology,
Right, of course.
we need to consider the potential downsides.
We can't just focus on the wow factor without addressing the potential risks.
It's like giving someone a powerful toolbox without the safety guidelines.
Exactly. You need to know how to use those tools responsibly.
Let's talk about those potential downsides. What are some concerns
Yeah.
surrounding?
Well, one concern is the potential for misuse.
Okay.
The ability to generate hyper-realistic synthetic data raises questions about authenticity and deception.
Okay.
It becomes increasingly difficult to distinguish between what's real and what's fake.
Like those deepfakes we've seen in the news. Videos manipulated.
Exactly. As GAN technology advances, we'll need robust methods for detecting and verifying the authenticity of the content. Otherwise, we risk eroding trust in information and media.
It seems like this constant cat and mouse game.
Yeah, right.
As GANs get better at generating fake content, the methods for detecting them also have to improve.
It's a challenge that researchers and developers are actively addressing.
Another concern is bias.
Right. In the synthetic data.
If a GAN is trained on a biased data set, it will likely generate data that reflects those same biases.
Yeah, if a GAN is trained on a data set of images that predominantly features one race or gender, it might generate synthetic images that perpetuate those imbalances.
And this could have real-world consequences. If it's used to train other AI models,
It could, absolutely.
or make decisions in areas like hiring or loan approvals.
Yeah, that's a critical point. It really highlights the need for careful consideration of the data used to train these systems.
So it's not just about the technology itself, it's about the humans
Yeah,
developing it.
exactly. We need to approach the development and deployment of GANs with a strong ethical framework, focusing on transparency, accountability, and fairness.
The future of GANs depends not just on technological advancements, but on responsible and ethical decision-making.
I couldn't agree more. As we continue to unlock the potential of GANs, we need to do so with careful consideration of their broader impact on society.
Well, this has been an incredibly insightful deep dive
It has been fascinating, and we hope
into the world of GANs.
it sparked your curiosity about the future of synthetic data.
We've explored their technical complexities, their amazing applications, and the ethical challenges that they present.
And its potential to reshape our world.
Thanks for joining us on the Bootstrapped AI podcast. And be sure to tune in next time for another episode in our Neural Knowledge series.